Hey everyone, good evening and welcome to our second logarithmic session of Toppr live classes powered by Toppr.com. Well, in our last class we had started the discussion about logarithms, a chapter which has its application in almost every chapter of mathematics. Without logarithm, we all know that calculations would have been a lot tedious. In fact, if you remember, then I had also told you about why logarithm came into picture. Well, it was because, in the early age when calculators were not there, the mathematicians needed something so that they could do complex calculations in lesser time, and that is where logarithm came into picture. So they developed this system of logarithm. Logarithm is rules to solve these arithmetic problems which they developed and they used to solve their complex problems. We also use logarithms in a lot of physics and chemistry applications, like in chemistry chapters. Like if you talk about in physics, actually if you talk about in chemistry log can be used to calculate the pH of acids and bases. We all know that if the pH, that is the negative log of H ion concentration, is greater than 7, then in that particular case the solution is basic, and if it is less than 7, then the solution is acidic. Similarly, it plays a great importance in physics also. In physics, you can use it in nuclear physics, where you calculate the half-life of any radioactive substance, and at a lot of other places depending upon the kind of question and the kind of application they want to ask you. So moving forward, I believe that if you were there in the last session, which you can always watch on our YouTube channel of Toppr, we had started the discussion of logarithms, and I had also discussed the laws or the characteristics of logarithm. So in this particular lecture, we'll deal more with the application part of logarithms, and keeping that thing in mind, the first thing that we are going to take is logarithmic equations. Now, to discuss these logarithmic equations, there is one thing which we will have to do once again today, and that would be the graph of a logarithmic function. I had given you a rough idea of how the graph of a logarithmic function looks like, but today we are going to discuss that in a bit more detail, and then we'll proceed with the questions of logarithmic equations. But before we start our today's class, I'll like to do my usual. Since I had told you that the first class of logarithm is on our YouTube channel, well, you wouldn't really get to watch it. In fact, you can actually watch it, but the point is that if you just watch it and just do not subscribe us, then you will definitely miss the notifications that we will give you for the next live classes on the various other topics. So it's not just logarithms that we are covering, we are actually covering almost every chapter that might that you might encounter in IIT JEE and NEET examinations of you all. So make sure guys that you are subscribing to our YouTube channel, liking us on Facebook, following us on Instagram, and keeping us in your circle in all the social media. Well, let's discuss our first topic or revision to what we have discussed was the graph of a logarithmic function. So we all know that if we're talking about graph of a logarithmic function, like as I have drawn in the last class, it is actually, the logarithmic function is actually an inverse of exponential function, and the graph looks like this. So it starts from negative infinity. I'm talking about the graph of log of x with base 2. You can also take the base as 10. It will just change the coordinates by some values, and the shape of the graphs will actually be same. One thing that is important to note here is that we don't really have to take the negative part of the x-axis for this logarithmic function, because log doesn't really exist for negative values of x. So unless there is a mod which is covering this x, you can really not have log of negative x or log of -3 or -5 or any other negative value for that matter. So let me just plot a couple of points on this graph. The first point is this, where the value of x is actually equal to 1 and the value of y is 0. We had discussed this in our last class that log of 1 with any defined base will always be equal to 0. which is why the coordinate over here is actually common to all the logarithmic functions. Each logarithmic function with any defined base will have its 0, that is y will be equal to 0 at x is equal to 1 only. And the reason that x is equal to 1 is the 0 is because a raised to the power 0 is equal to 1 for any real a except for 0 in exponential function. So this actually is the reason that why we are having 1 comma 0 as a point common in all the logarithmic functions. That being said, there are for particular values, and in fact a particular, you can say, a trend which this logarithmic function is following, and you can see that it starts from negative infinity, that is from minus y axis itself. If you take care of this, you will see that it starts from negative infinity, or negative infinity se hota hua right from cutting this 1 comma 0, it goes towards positive infinity. Why is this trend there, however? Well, this trend is there, however, because there is a property of logarithmic functions which we need to know, and that is कि अगर हमारे पास में एक logarithmic function है y is equal to log of x to the base a, then this particular value, well, it will be positive and negative based on the values of x and a. So you can say that the value of your y will actually be equal to positive, or will be positive, if x and a, that is if the values of the base and the value of the value which is of which logarithm you want to find, they both are lying on the same side of x is equal to 1. So you can say that y will be positive if x comma a both are greater than 1, and at the same time it will again be positive if x comma a both are less than 1. Now that means if our x and a, they are on the either side of 1, then this will mean that the value of y should be negative. Well, yes, of course it will be, but first let's see that how will this create a positive value, or how can I take this from this particular equation or this particular logarithmic function. So यहाँ पे आप देख सकते हैं कि हमारा जो log है उसका जो base है वो है 2. I can see कि अगर हमारा जो log का base है, well, sorry for the delay guys, but well, I've already told you about my logistics team. They always want the things to be perfect, which is why they have made some changes with the screen, and I think that you can now view the content in a much better way. Actually, I can say that because I can also view it quite better now. So yeah, thanks to them, and sorry for the delay. Sorry to you once again. Now let's get back to the things that we were discussing. I was talking about the trend that this graph is following, and I can see that, well, if the value of x is less than 1, so since this is the point where x is equal to 1, then for x less than 1, you can see that the graph is along the negative y-axis. Since it is along the negative y-axis, it pretty much signifies that for this to be positive, it has to be on the same side of the value of a. A over here is equal to 2. So our a is equal to 2. That means for y to be positive, our x should also have to be greater than 1. And so you can see that once the value of x crosses 1, that is after this 1 comma 0, you'll see that there is an increasing trend in the values of y. That is, the graph is moving towards positive y-axis. In fact, it is moving towards positive infinity, right guys? So this is why you can see that this basically how is we can explain the trend of a logarithmic function in terms of its graph and in relation with its values. Similarly, now I can say that y will actually be equal to negative if the value of x is greater than 1 and that of a is less than 1, or if the value of x is less than 1 and that of a is greater than 1. That being said, if I have to draw a graph in which the base is actually, well, less than 1, then how would it look? Well, it is going to look more like the like this graph only, it's just going to be in the different directions. So if I have to draw this graph, the graph is, well, this, and now this time the graph will start dropping from the positive y-axis and it will drop towards the negative y-axis. So for this you can say that the y is equal to log of x to the base 1 by 2. Here you can see that the moment it crosses 1, 0, that is after x is equal to 1, the value of y, or the results that we are getting, is on the negative side. So even though the values of x are greater than 1, the values of y are less than 0, which proves that if we have to find, or if we have to say that the value of y is negative, well, x has to be greater than 1 and a has to be less than 1, and of course greater than 0. So these are the things and these are the conditions that you should be aware of if you are talking about a logarithmic function, if you are talking about the graph of a logarithmic function. And keeping these equations, in fact these conditions and the characteristics that we discussed in the last class in mind, let us now discuss some questions of logarithmic equations. So my first question is actually a very simple one. Let me just write down that question for you. The question is, how many roots does the equation log of x minus 3 with base 2 plus log of 1 minus x with base 2 equal to 3 has? Well, the problem with this, the one thing that I would want to change in this question is that this x minus 3 is actually 3 minus x. So let me just replace it with 3 minus x. So now my equation is actually log of 3 minus x to the base 2 plus log of 1 minus x to the base 2 is equal to 3. We have to find out that how many roots does this equation has, and for that matter what I'll do, I'll try to solve this equation by taking in consideration the condition and the characteristics of logarithm. Well, by the characteristics, the first thing that we know, and by the definition of logarithmic function itself, the first thing that we know is that whatever the value whose logarithm we have to find, well, it has to be greater than 0. That means I can pretty much say that my 3 minus x has to be greater than 0, and at the same time my 1 minus x also has to be greater than 0. So taking this one further, I will get the value of my x as less than 3, and from this I'm going to get the value of x as less than 1. So these are the two conditions that we'll have to make sure to implement when we finally get the solution of our equation. Now let's just write the equation that is given to us. So the equation given to us is log of 3 minus x to the base 2 plus log of 1 minus x to the base 2 is equal to 3. I can clearly see that in both these equations the values of base are equal, and since the bases are equal, all we have to do is apply the property that log of m plus log of n is equal to log of m into n. So let's just apply this, and this pretty much will simplify our question. So it basically will make log of 3 minus x with base 2 plus log of 1 minus x with base 2 equal to 3, and convert it to log of 3 minus x times 1 minus x to the base 2 is equal to 3. Now guys, whenever we arrive at such particular condition in a logarithmic question, all we have to do is move this base to this side. That is, we go from the logarithmic function to the exponential function. So we are going to do the same thing over here as well. We all know that a raised to the power x is equal to n, which means that if I have to convert this logarithmic function into that form, a raised to the power x is equal to n, all I have to do is make sure that I'm substituting the correct values in place of the base, the exponent and the result of it. So by that understanding, I can clearly say that my base will be 2, the exponent will be 3, and this will be equal to 3 minus x times 1 minus x. Yes or no, guys? So I believe that if you had seen this, if you were in the last lecture or if you already know the basics of logarithm, you'll be easily able to make out this equation from what we have discussed. And now we can simplify this equation as any normal quadratic equation. So let's try and do that. I can clearly see that 2 raised to the power 3 is equal to 3 minus x times 1 minus x. So all I have to do now is simplify this equation to get the value of x. So for that I can say that 3 minus x times 1 minus x can actually be written as x square minus 3x minus x, that is minus 4x plus 3 is equal to 8. Right or not, guys? So all I did is simplify these two polynomials. So you simplify these two polynomials by multiplication and you will get this equation as the result. So now you can say that x square minus 4x plus 3 minus 8 is equal to 0. So since it is x square minus 4x plus 3 minus 8 is equal to 0, now I can simplify it further and I'll get x square minus 4x minus 5 is equal to 0. Now it's a normal quadratic equation that we can solve by a couple of methods. You can use the Sridharacharya's formula, or you can even solve it by factorization method if you are good at it. I can clearly see that this particular equation, that is, it can be factorized further. So by factorization, I have to form, or I have to split this middle term into two factors such that the sum or difference of that gives me minus 4x back and the product gives me, well, this constant term. So let's just take that further. All I have to do is say that this can be splitted in minus 5x times x, and that will give me this coefficient, this constant term and the multiplication of the first term as well. So I would get x square minus 5x plus x minus 5 is equal to 0. Now all I have to do is take the value of take x as common from the first two terms. It will get me x times x minus 5, and in these two terms there is nothing common, so we take 1 as common by default, and in the bracket I'll again have x minus 5 and this will be equal to 0. In these two terms again I can see that x minus 5 is common, and since x minus 5 is common, I'll take this x minus 5 as x minus 5 outside, and in the bracket we'll be left with x in the first term and plus 1 in the second term. So this basically gives me x minus 5 times x plus 1 is equal to 0, or you can say that there are two values of x for which will satisfy this particular equation, which is x is equal to 5 and x is equal to minus 1. But do you think that both of these are actually your roots? Well, let's get back a little. So over here you can see that these are the two conditions that we that we'll have to follow in choosing the values of x. Now by these two conditions, what you can see is that the value of x has to be less than 3 and not greater than 3. In fact, if you take the union with this x less than 1 also, you'll see that now the value of x has to be less than 1 for this equation to even exist. Which is why this value x is equal to 5, it will be rejected. You can even try this out by putting the value of 5 in these two equations, that in these two expressions. You'll get 3 minus 5 which is minus 2 and 1 minus 5 which is minus 4. In both of the cases you can see that the log of negative value is coming, which doesn't really exist. And that is why you can say that x is equal to minus 1 is the only solution or only root of the given logarithmic expression. So guys, the answer would simply be one root is actually the, the roots of this particular equation. Now, this was quite a simple method of doing these kinds of questions. However, whenever you are asked questions on roots, that is how many roots the equation will have, I would suggest that if you can solve the equations quickly, it will be this method which you should go for. Otherwise, you can always assume values for x and try to solve this equation by hit and trial method. You can simply multiply these two values and you will have to finally think on these two values giving you 8 as the product, and when you will factorize it, you will see that there are only very few cases in which these two terms can actually give you the result as 8. When you will take care of all those factors, you will understand that there is only one possibility which will solve this equation of yours, or which will satisfy this equation of yours, and hence one root is only solution, or one root will only be possible to satisfy this logarithmic equation. So with that hope guys, I believe that you've understood this question. And now let's take this particular topic, let's logarithmic equations, by up a notch, and let's discuss a question which came in JEE. So it's important for us to understand a question that came directly in JEE, because well, usually in JEE we don't really get to we don't really get direct logarithmic questions. So this question, it could be a bit difficult and a bit lengthy to solve. However, upon solving it, I'm pretty sure that you'll understand the different ways of applying logarithms in different questions. So now we'll have that question on our screen. So I believe guys that now the question is visible to you all on your screen. The question for, well, let me just read the question for your sake once again. So if 2x raised to the power ln 2 is equal to 3y raised to the power ln 3 and 3 raised to the power ln x is equal to 2 raised to the power ln y, and x naught comma y naught is the solution of these equations, then the value of x naught is. So what do you think we can do in these kinds of questions? So this question is actually simple enough. If if you think about it, all we have to do is find that value of x0 which will satisfy, or with the value of x which will satisfy this equation of ours. But the solution, however, when you will do it, you'll understand that the equations become some complicated ones, and which is why it would have been quite wise to solve this question at the end of your paper. Just for covering the entire logarithmic applications, it's important for us to do this question so that we can understand the various properties in the process, and at the same time discuss the understand the basic concepts involved in solving it. So let us start with whatever is given to us. I can clearly see that the first thing which is given to us is that 2x raised to the power ln 2 is equal to 3y raised to the power ln 3. So I can see that this basically is my first equation, and my second equation is 3 raised to the power ln x is equal to 2 raised to the power ln y. Now guys, if you remember, ln is nothing but log with its natural base, which is e. So this is actually log of x to the base e, or log of y to the base e. Now what we'll do, we'll start with this equation 2 first, and we'll start by taking log on both the sides. So let's start by taking log on both sides. So if you'll start by taking log on both sides, what you will get is log of 3 to the base, log of 3 raised to the power ln x actually equals log of 2 raised to the power ln y. We know that since log of a raised to the power m is equal to m times log a, so what we will do, we'll simply multiply these exponents of 3 and 2 to the logarithms itself. So we will get log 3 times log x with base e equals log 2 times log of y to the base e. So from this, if you try to get the value of log of y, you'll see that log of y to the base e actually equals log 3 times log x with base e divided by log of 2. Now here you might ask a question that why are we substituting in place of log of y? Well, we are substituting in place of log of y to the base e, and because we ultimately want to find the value of x naught first, which is why wherever we are encountering y, we will try to avoid it and we'll try to substitute it by x in some way, so that ultimately the logarithmic equation that is left with us is in terms of x only, and hence helping us find the value of x naught faster. So now what we have to do is take log on both the sides again in equation 1. So I think doing that would not be difficult now that we've already understood how to take log on both sides. So this, however, will give us ln2 times log of 2x. Well, I have taken the exponents as the coefficients of log earlier itself by this particular property. So I could simply say that ln2 or log 2 with base e is times log 2x is equal to log 3 or ln 3 times log of 3y. Now guys, an important thing to note over here is that there are two values in the product, and we would really not want these values to stick together, because ultimately we want to find the value of x and we want to substitute in place of y. So what we'll do, well, we know that since log mn is equal to log of m plus log of n, we are going to use this property in this equation. So this is going to give us log 2 with base e times log 2 plus log x is equal to, well, over here you can see that all values are with base e only, so I'm just going to write base e in almost all of them. I'm taking log also on both sides with base e also, which is why I have to write e here as well. So wherever you have forgotten to write base as e, you can simply mention that while you are solving your question. It sends up to your understanding, so you don't really have to mention it. However, in subjective way of solving this question, you'll have to mention that you are taking the base as the natural base of log. So now the right hand side will become log of 3 with base e times log 3 plus log y. So I believe, guys, now is the time where we have to substitute the value of log y from this third equation to this particular part of the equation. So when you'll do that, it will become log 2. Now I'm just ignoring e everywhere. So log 2 times log 2 plus log x is equal to log of 3 times log of 3 plus, now instead of log y, we are going to write log 3 times log x divided by log 2. Now just make sure that you are taking LCM properly. So when you will do that, you are going to get log 2 times log 2 plus log x is equal to log 3 into log 3 times log 2 plus log 3 times log x, and the entire base will be log 2. Now you can simply cross multiply this log 2 on the other side, which is going to give you log square 2 times log 2 plus log 3 plus log x equal to, now you can see that log 3 is common in the entire bracket, so which is why you're going to take it common. This is going to give you log square 3, and in the bracket you will have log 2 plus log x. Now we have reached to a part of the equation where we have a lot of values that are common in both LHS and as well as the RHS. Now what you have to do is make sure that the values that you have multiplied and corrected are actually clear and correct is with respect to each other. So over here, by expanding these brackets, when you'll solve these brackets, what you're going to get is log 2 will be multiplied with log x, log square 2 will be multiplied with this log x, and similarly, actually when you do it in this particular step, you will not really have to what you can say is simplify it further. So what you will do, the next part that you have to do is try to simplify this equation, and upon simplification you are going to reach to this place, that log square 2 minus log square 3 is actually equal to log x times log square 3 upon log 2 minus log 2 times log x. So guys, make sure that you are reaching this particular step. So there could be a simple simplification of multiplying the values, taking commons and further. So from this particular step, when you will take it ahead, you need to understand that the equation that we have got is something that we are further simplifying. So let us now take the last step once again. So the last step that we have written was log square 2 minus log square 3 is equal to log x times log square 3 upon log 2 minus log 2 times log x. So now guys, this equation has come to a very sensitive point where we have to make sure that we are not making any kind of mistake in simplifying it. So all we have to do is just make sure that the values are converted in this form again. So log square 2 minus log square 3 will be equal to log x times log square 3 minus log square 2 times log x upon log x. What you can do is upon log 2. So from here what you can simply do is take log x common in the right hand side. So it will give you log square 2 minus log square 3 is equal to log x common log square 3 minus log square 2 upon log of 2. Now over here it is quite easy for us to cancel these two values, but for that also we'll have to first take -1 common from here, or what we can do is simply cancel this and write -1 here. So by this means I would say that log x is actually equal to log 2, and there's a minus sign because of this -1, which implies that log x is actually equal to log of 1 by 2, as this -1 will go in the power of 2, in the exponent of 2, and will make it 1 by 2. And you can simplify it further for getting the value of x, which is x is equal to 1 by 2. So the value that we will have to the value of x that will satisfy our logarithmic equation will be x is equal to 1 by 2. Correct guys? So this is where our solution ends, and you can see that option C is the correct answer. However, in exams, I would suggest that these kinds of questions, they should always be attempted at the end, because it will require your, well, constant effort and I can say a lot of attention for finding the value of x by this particular method. Feel free to drop us any, like, better solution if you have for this particular question. We would like to we'll definitely get back to you with that, and we'll try to put that on our website. Now, since we are doing questions on logarithmic equations, let me tell you that these questions are there from the question bank of Toppr.com, which means that you can practice a lot more questions on Toppr. And to practice a lot more questions on Toppr, you'll have to sign up on our website www.toppr.com. So we provide all kinds of questions on topics of IIT, JEE and NEET, and every chapter of PCMB is there for you to cover. And of course, there are going to be a lot more live classes, a lot more live sessions on various different topics, which you can see on our YouTube channel. And to make sure that you do attend all of them, well, there is an option of getting the notifications of all, and for all those notifications you need to subscribe to our YouTube channel, like us on Facebook, and follow us on Instagram for all the further updates. So guys, with this particular question is something that we can give a rest now. Now the next topic that we are going to discuss is another application of logarithm. And well, let me just remove this question from your screen. So so now we can simply discuss that topic, which is logarithmic inequality. So like equations, we can also have inequations in logarithmic terms, on logarithmic functions. And to solve those inequations, what we have to do is, well, again take care of the conditions and the properties of logarithm. The definition of logarithm and the conditions that we have, well, put on, the constraints that we have put on a, b and x while defining logarithms, they play quite an important role in solving a logarithmic inequality. Like per se, or for that matter, if you simply take care of, if we simply look at a logarithmic inequality might look like log of x to the base a as greater than 0. So if, let's say that we are taking this logarithmic inequality, then you can clearly see that what this particular value wants, or what this particular expression wants, is a result of log x to the base a, which is positive. So if your y is equal to log of x to the base a is greater than 0, that means the value of y is positive. And if you remember, then at the very start of this session, we had discussed that under which circumstances we will get the value of y as positive. Well, it will be for both a and x lying on the either side of the value 1 that we will get the value of y as positive. Just for a brief revision, let's just take a look at the graph. So if you have y is equal to log x with base 2, the graph goes like this. That means after x is equal to 1, it will show positive values since the base is greater than 1. And then again, if you are talking about a graph of log with base as 1 by 2, well, the values will actually decrease, or the value of y will be negative after x is equal to 1. So this is how the graph follows, or the graph shows the trend based on the values of your base. If the base is greater than 1, then your x also has to be greater than 1 for your logarithm to be positive. If your base is less than 1 but greater than 0, then your x also has to be less than 1 but greater than 0 for a positive result. So with that thing in mind, let's discuss a couple of questions on logarithmic inequality as well. And the first one is actually a simple one, and that is, solve the inequality. So let's just take a look at the inequality, and that is log of 1.5, log to the base 1.5 of 2x minus 8 upon x minus 2 as greater than 0. So guys, what are your thoughts on this particular question? How do you think that we can solve this one? Well, from the conditions that we've already discussed about logarithm, the first thing that's for sure is that the base is greater than 1. Since your base is greater than 1, then it is this value or this graph that is applicable to your inequality. And we've already seen that if you want for base greater than 1, if you want your logarithm to be positive, then your value of x also has to be greater than 1. So since it also has to be greater than 1, it clearly simplifies our problem. All we have to do now is say that 2x minus 8 upon x minus 2 has to be greater than 1. Well, of course, this is the only condition that we have to simplify now. And now make sure that you are not really cross multiplying this x minus 2 on the other side. And the reason is that this x is a variable. It can take a positive value and it can also take a negative value, which is why we can't really cross multiply it, because the value of the denominator is uncertain. However, what we can actually do is bring this 1 from the right hand side to the left hand side, and it will become 2x minus 8 upon x minus 1 upon x minus 2 minus 1 as greater than 0. For further simplification, you can simply say that 2x minus 8 minus 1 times x minus 2 whole upon x minus 2 is greater than 0. Let's take this particular one further. So this, however, this will give us 2x minus 8 minus x plus 2 upon x minus 2 as greater than 0. Let's simplify this one. 2x minus x is x, minus 8 plus 2 is minus 6 upon x minus 2 is greater than 0. So guys, we have finally come to that part of our inequality where we now just have to find the values of x that will satisfy our final condition. And for this one we'll have to take a number line, a real number line, and on this we'll have two critical points, one at x is equal to 2 and the other one at x is equal to 6. I can clearly see that there is no equal to sign in this particular equation, which is why I'll make both of them, or I'll depict both of them with open dots or open circles, because they are not included in the solution interval. Now all we have to do is take one value from these three intervals and see that which of these values are satisfying our condition. The one that's satisfying is a solution set for our given inequality. So if I take the value of x greater than 6, let's say if I take 7, then 7 minus 6 is positive, 7 minus 2 is positive. So positive upon positive is greater than 0, which is why this particular part is there in our solution. Now if I take a value which is between 2 and 6, then let's say for x is equal to 4, if we try, then 4 minus 6 is negative and divided by 4 minus 2, which is positive. So this negative upon positive will always be less than 0, which means that this is not there in our solution set. And finally, for this third interval, for a value which is less than 2, I can simply put x as 0, and 0 minus 6 is minus 6, that is a negative value, and so is 0 minus 2, which is minus 2, again a negative value. That means negative upon negative, which upon simplification will give us positive, which is greater than 0. Thus I can say that this particular interval also lies in our solution set. So from these two values, or from these two intervals, I can see that my x, it belongs to negative infinity to 2 union 6 comma infinity. So this right here, guys, is the solution of our logarithmic inequality. So I hope you understood this very basic concept of logarithmic inequality. There wasn't really difficult in this particular problem. However, there could be a lot of different problems in which there could be application of different concepts which you might have to take care of while solving the inequality. And so for that, keeping that thing in mind, let's discuss one more question on logarithmic inequality before signing off from the session. And that one function, or that one question, is well, an easy one but a bit tricky one. So the question is actually quite simple. We have to find the value of x for which log of x with base 1 by 2 is greater than log of x with base 1 by 3. This question is a bit different from the question that we have done earlier, and the reason is that the base over here you can clearly see it's less than 1, which means that the graphical trend which will follow will be from positive to negative. That is, for values of x greater than 0 but less than 1 it will be positive, and the values of x greater than 1 it will be negative. So guys, now all we have to do is solve this question. So let us first just write our expression. So we have been given log of x to the base 1 by 2 minus log x to the base 1 by 3 as greater than 0. What I can see over here is that the expression which is given to us has two logarithmic functions, and both of them have different bases. Well, we've already discussed in properties of logarithms and characteristics that if we want to perform operations or if you want to apply any law of logarithm on two logarithmic functions, then their base has to be same. So keeping that thing in mind, what I'll try to do is make the base of log of x to the base 1 by 3 as 2 only, as 1 by 2 only. So what you will get is log of x to the base 1 by 2 minus log of x to the base 1 by 3 divided by, or we can simply write this one itself, log of x to the base 1 by 2 and log of 1 by 3 to the base 1 by 2. This is greater than 0. Now for the reason, I can say that since log of a by b, well, log of a by b can actually be written as log of a with base c upon log of b with base c. So all I have done is taken this particular value and we have rewritten this in this value, or in terms of this value, by taking care of this property. So now let's just take a look at this one, this one question, and then we'll take one question which has been sent to us by our viewer, and let's just first solve this one. So let's complete the solution of the question that's already at our hand. Now in this particular question you can see that now you've already got log of x to the base 1 by 2 common in both the equations. So what I can do is write this, take this one common, and I can write this one as 1 minus 1 upon log of 1 by 3 times 1 by 2, to the base 1 by 2, and the entire equation is greater than 0. What I can now do is simplify this equation further. So for that matter, upon simplification, we are going to get log of x to the base 1 by 2 times 1 minus log of 2 to the base 3 as greater than 0. We could do this because, well, 1 by 2 could be written as 2 raised to the power minus 1, and so can this log of 1 by 3, and these minus ones, they basically will cancel each other, and log of a to the base b is equal to log of b to the base a, right guys? So from this particular point is where you can, try to depict values or try to find the conclusions, jump on the conclusions for the inequality to exist or to satisfy. So what you can do is consider this one function first of all, this part of the expression. So we know that log of 2 to the base 3 is less than 1 but greater than 0. The reason is that the base, so the value of logarithm will always be greater than 1 only if it is greater than the base in case of both a and x lying on the right side of 1. So for this means that this particular value will be greater than 0 but less than 1. This implies that 1 minus log of 2 with base 3 is always positive. So if this value is always positive, then this means that now we will have to make sure that log of x to the base 1 by 2 is also greater than 0. And we all know from the properties of logarithm that for this value to be greater than 0, that is for y to be positive, both the base and x has to lie on the same side of the x-axis or same side of 1. I can clearly see that my base, which is 1 by 2, is greater than 0 but less than 1, and hence the value of x also has to be greater than 0 and less than 1, which means that this over here is the solution of your inequality. So guys, make sure when you are solving this question, solving these kinds of questions, then well, that time you're taking care of all these kinds of constraints in in consideration, and you're not solving them without thinking about the properties and the characteristics you can apply to it. So let's now get back to our viewers once again before signing off. So I had a question thrown at thrown in the YouTube comment section, and I just take a look at this question before starting to solve to solve it. So the question was quite was from logarithmic equations, and I can see that the question is log of x minus 3 to the base 10 upon log of x square minus 21 with base 10 is equal to 1 by 2. Cool. So that's actually a good question to solve. So let us now try and solve this question, guys. Now while we are solving this question, I also would like you to give it a try, because we've already solved a question on logarithmic functions, and I believe that you already know the properties and the constraints involved to solve this one. So the first thing that I'm going to do is make sure that this value and this value, they does exist for the logarithm, which is why I can say that my x minus 3 has to be greater than 0. And at the same time, so if x minus 3 is greater than 0, then this means that x will be equal to 3. And then at the same time, x square minus 21 also has to be greater than 0. So if x square minus 21 has to be greater than 0, I could simply say that x minus root 21 times x plus root 21 would be greater than 0, or you can say that x belongs to minus root 21 to plus root 21. One more thing that we have to, that we can actually apply right over here itself. So we know that log of a to the base b upon log of c to the base b, well, this can actually be written as log of a to the base c itself. So since this is the case, what we can do now is rewrite the first term, or rewrite the left hand side of our expression as log of x minus 3 times to the base x square minus 21 is equal to 1 by 2. Now guys, there is this, so okay, so there is this one problem which I have not really thought about. So since it is greater than 0, the solution would not really be this. X actually will belong to negative infinity to minus root 21, and then union root 21 to infinity. Apologies for the incorrect segment. Now log of x minus 3 to the base x square minus 21 is equal to 1 by 2. All you have to do is now simplify it with the usual way, and for that matter what I can do is simply send this x square minus 21 on this particular end. So this particular logarithmic equation, it would be rewritten as x minus 3 is equal to x square minus 21 whole raised to the power 1 by 2. or I can say that this would be x minus 3 is equal to square root of x square minus 21. So now guys, while you are doing it, we need to make sure of one thing, that since this is an equation, it really wouldn't matter in this particular case. However, in other case it might. That since this x square minus 21 is in the base, so this x square minus 21 cannot equal to 1 as well, cannot be equal to 1 as well now. So you need to take care of that thing as well while solving it. So let's just first solve it, and then we'll see that which values of x can be a part of this solution set and which values of x can really not be. So now we can say that x minus 3 whole square will be equal to x square minus 21 upon squaring both the sides, and upon simplification you can see that x square minus 6x plus 9 is equal to x square minus 21, and at the same time, well, x square and x square, well, you can simply cancel them. You can send this minus 21 on this side and minus 6x on the other. You'll get 6x is equal to 21 plus 9, and then you can further solve it as 6x is equal to 30. That means x is equal to 5. So x is equal to 5 is one solution that we have obtained. In fact, it is the only solution possible, but it's important for us to understand that whether this solution follows our other conditions or not. So for that matter, I can clearly see that the value of x, well, it has to be greater than 3, so it matches this one. X is equal to 5 is actually equal to square root of 25, which means that it will lie in this interval also. And finally, x square minus 21 cannot be equal to 1. So that means x square not equal to 22, or x, well, it cannot be equal to minus square root 22 and plus square root 22, which again is, well, pretty much plausible in this case, which means x is equal to 5 is the solution of the given logarithmic expression, given logarithmic equation. Fine guys, so I think this particular solution would clear your query. Now there is just one more question which involves logarithmic function and a modulus function, which we should do. And for that one, well, let's just make some space first. The question is, well, it's actually a pretty normal question. The question is log of mod of 2x minus 7 is equal to 1 and the base of the logarithm is 3. So guys, the first thing that you have to do in these kinds of question is make sure that you are simplifying it in terms of the exponential function. So this would make your mod of 2x minus 7 equal to 3. But then since there is a modulus function involved, there is an extra thing which we have to do in this question, and that extra thing is that when this modulus sign will be ignored, 2x minus 7, well, it will be equal to plus 3 also, or 2x minus 7 can be equal to minus 3 also. The reason is that upon the removal of modulus sign, the absolute function is actually does not exist, and because of the absolute function we would ignoring the negative sign of this minus 3, which is why this also is a possibility. So let's just solve both these equations. So when you'll say that 2x minus 7 is equal to 3, you'll simply send this 3 on the other side and you'll get the value of x as 5. You can put the value of x as 5 in this logarithmic equation of yours. It will give you log of 2 times 5, that is 10 minus 7, which is 3, and log of 3 to the base 3 is equal to 1 only. And in a similar manner, you can simply send this minus 7 on the other side and you will get, well, 2x minus 7 is equal to minus 3 plus 7, or you can say 2x is equal to 4 or x is equal to 2. So your x is equal to 2 is also a possibility, and that's because when you will put x is equal to 2, the value that you are going to get is 2 times 2, that is 4, and 4 minus 7 gives you minus 3. So modulus of minus 3 is 3 again, which is why log of 3 to the base 3 will give you the result as 1. So in this particular case guys, there will be two values of x that will satisfy our given equation, x is equal to 5 and x is equal to 2. So I hope this clears your doubt here. and I hope moving forward you'll be able to solve these kinds of questions. So guys, this basically brings us to the end of our session. I hope that this session was particularly useful to you, useful for every one of you, as in this particular session we had discussed the applications of logarithms, the kinds of questions that we are going to get, or the kind of places where we'll encounter logarithms in our examination. Well, for our next session we will be having a physics session on Friday, and for that session the topic that we'll be covering would be laws of motion, which I know is a very important topic and one of the favorite topics of the IIT, JEE and NEET examinees, right guys? So make sure that you are attending that session of ours, and to you can definitely get the idea or get the link of that session on our YouTube channel. But then again, if you want to be on while you are on the YouTube channel, there is this one more question, which is, sorry, that wasn't a question actually, it was Harsh who had thanked me. And Harsh, I'm actually very grateful to you, and I'm quite happy that I was able to make you understand the concept of logarithms. So guys, anyway, I was talking about the physics session that we are going to have on Friday, so make sure that you guys are attending it. We'll be coming up with a lot more sessions like this one and the session on Friday in the coming weeks for the detailed notification set and everything. You need to subscribe to our YouTube channel. You have to like us on Facebook, follow us on Instagram, keep us in your social media circle, so that we can basically teach you, guide you and help you get better marks in your examinations. Well, as anybody would, and at our organization would say, we are there for you. We are standing right beside you. So guys, with that note, I thank everyone who was there in the session and who liked it. We will definitely take your feedbacks and comments, and if there was any doubt which was left unanswered, I would say that you should write to us on support@toppr.com. We would make sure that we come back to, we would get back to you with the doubts, and you can simply comment also. You can simply comment your doubt also on this on this particular video, and some of our experts would get back to you with the solution or the resolution of your query. With that note guys, bye bye, take care, all the best, happy learning.